This is Anthony Manning, and this is for the physics final, the third question. The question stated that there's a mass suspended to a ceiling, and there is a 5-meter separation of these two ropes that are keeping it attached to the ceiling. One rope is 3 meters long and the other is 4, and this means that they'll have completely different tensions in each of the strings. I had a lot of difficulty actually setting this up before I tried a 3-4-5 triangle, and setting these up as the ropes are straight down connected to the mast started to become just very difficult. But due to like triangles and like the opposite angles of these triangles, these were the actual angles that these vectors work out to be. So once I got that established, my X number of 112, I started to just make all the net forces, which the total net forces like in the X direction should be balanced. So it should be T1 is pretty much equal to T2 because it's not moving. The total isn't moving. And when solving for that, it would just be the tension 1 times cosine 53 is equal to the tension 2 times cosine 37. Now, that gave me a total of 1.327 times tension 2. And that was what I got for tension 2. And I'm going to take that formula and then start to solve for the y. And as I solve for the y, I'm going to then use the formula in the same way just to plug in for tension 1 and then substitute. With that substitution, it leads me to getting that T2 is actually equaled to 660.5 newtons. And then from there, I can just plug back into this formula and solve for T1, which it gave me 800 and just say 76 newtons of force in the string. Past that, I did a self-check just to make sure that all the forces balanced out, both in the y and x directions. And the weight with the gravity and the mass of this object was just say about 1100, and all of the numbers tied out properly, so that means that it is going to stay there and it's going to be in a no velocity, no acceleration state. Thank you, Professor.